Okay, y'all, so the purpose of this video is to walk you through gizmos and how to maneuver the gizmos to get the answers that you're looking for. So you should have that worksheet that Mr. Glover passed out. And I just went over in another video this right here, so I'm not going to go back over it again. But my plan for this is to make sure that you can complete your warm-up. And basically, all that warm-up, as I showed you in the previous video, is you going to click on this in Schoology, and it'll take you to your warm-up, have your definitions out. Just in case you didn't have your definitions, I put a link to the definitions up there. And all you're doing is matching the term with the correct definitions. Then we're going to go to your worksheet with gizmos, seasons, earth, moon, and sun. You'll pull that up on your gizmos. You need to go through ClassLink to pull it up. We're going to try to go through activities A and B, and I'll show you where to get a little help for C. Again, go through ClassLink, go to Gizmos. If this is your first time, you'll need to type in the username that you see at the bottom so that you can click into the class. And now let's get started. So just to remind you that that axis is at a 23.5 degree tilt through the Earth's center, that the Earth spins on its axis, and that's what gives us our 24 hours in a day. The Earth revolves or takes a lap around the sun, and that's what gives us our year, 365 days. On a leap year, it's 366. Because it's at that little tilt on its axis, we will have days where we are completely within the sun's rays. It feels hotter, the days are longer, and we know that to be summer. And then after summer, we know we slide on into fall, and that's when the Earth is starting not to have as much of the direct sun rays from the sun, and our days will start to shorten for the light, and we'll see more in the evening. The equinoxes or the autumnal equinox, it symbolizes our start for fall, but it also shows us that there's equal numbers of daylight hours and nighttime hours. We'll have one more equinox that happens in the spring. We call it the vernal equinox, again, where the day has an equal number of daylight and nighttime. So Earth's tilt and its seasons, if you're looking at it this way, well, hold on a minute. Let me move this out the way so you could see it a little better. Just going to move that down here. Y'all remember down there is the South Pole. Okay. So when I'm looking at this, here's my Earth. When I'm looking at the United States, it's right about here. So as I start to rotate around, when I'm facing the sun, I'm going to be more in the summer, and my days will be longer. Remember, this is rotating, but my whole Earth is pointed towards the sun. So that's the point. Even though I know my United States is over here, that means I'm just in nighttime. And as it keeps rotating on its axis, it's going to be daytime, and that sun's rays is going to be extremely close. Right now we see it extremely close on Africa. Over here, as the Earth keeps rotating around counterclockwise, over here, I see that the sun is a little further from the Earth. It's not tilted towards, but tilted away, which means that my days will be a little shorter as far as the light outside would go, and the temperatures would be typically a lot cooler. So my seasons happen because of the tilt of the earth as the earth is taking its lap around the sun. And so one more time, if I'm looking at equal fall or equal days for the light and the dark, um, we call it the equinox. That's autumnal, and that's for the fall, or spring, and that's for vernal, and that's when I've got the equals. And then my solstices, when in December 22nd, it is the tilted away, which means my days will be the shortest, which means typically the day would be colder. And then in June, my summer solstice, I'm pointed more towards the sun. The days will be longer and typically hotter. So when it comes to your worksheet, I want you to answer the first two on your own, and then get ready to do the simulation. You're going to drag that little simulator and just make sure it's at the very far left. So when it's at the very far left, I expect the speed to be slow enough for you to see what's going on. We're going to see the Earth travel around the sun counterclockwise while the moon travels around the Earth. So with that being said, let me say very quickly, we know the Earth spinning around on its axis gives us our 24-hour days. We know that the Earth taking a lap around the sun in counterclockwise motion, we know that's going to be our year. To get our month, that is the moon traveling around the Earth. So one complete lap around the Earth gives us each of our months. So let me go to that real quick. Feel free to replay the video when you need to. So I have it set on the very minimal. Let me make sure I'm on that part. So I'm going to show you a few different angles. So as you can see, my Earth is spinning on its axis. That's the axis right there. And I'm seeing day and then night. Let me show it to you down here. Again, let's see, here is, I'm trying to see if I can see it. Here's the U.S. It's spinning around. When we see it come back around, so we're looking at that little red dot as it comes around. You can look at other dots as it comes around if you want to put one. We're going to do one for your latitude, but you can see the difference between day and night. I was trying to give it a little bit more time so we can see that moon come on around. So as you can see, the Earth is traveling on its own axis around the sun, but it's spinning while it's traveling around the sun. And we see the moon is traveling around the Earth. Now, on this one, we're looking on top from the Earth. On this one, we're looking at the side view. Let me show you my 2D version. In the 2D version, as you can see, we have the sun rising in the east and setting in the west. So as you see it get lighter over here, we see the sun and the moon come up and the sun and the moon setting. Round the clock, depending on what time of year it is, we'll see more daylight or we'll see less daylight. Let me show you the graph with the solar intensity. In other words, how much sunlight intensity is going to be. We see it go up when the sun is at the highest and then go back down when it's time for night. So we see sunrise and sunset, and we see how much of that sun is intense. And we also see how many hours we get for daylight. And then let me point something out with the shadows. So again, I'm looking straight on top. If I'm looking overhead, that's that little angle over here. If I am looking from the side, then I get to see the actual shadow. So let me show it to you one more time. So when I'm looking at this, I see that the sun is going to go rise in the east and settle in the west. Again, the sun is rising in the east and settles in the west. Your shadow is going to be a mirror of what you see. It is going to rise in the west and settle in the east. Very same movement, just a mirror of the movement. So if you look down here, again, my sun is rising in the east, settling in the west, but that shadow goes from west to east. There's one more thing I need to show you about this shadow. When I'm looking from the side of it, that shadow stick looks really long. When I'm looking from on top of it, it looks shorter. And so when we're looking on top, that's when the sun is at the highest point. So at the highest point, the highest altitude, my shadow stick looks at like it's at its shortest, but then it gains its length again. Feel free to go back and rewind that video in case you need to see it again. But what I'm saying one more time, when that shadow is looking from the sun at its highest, the shadow is going to be the shortest because it's looking straight on top. All right, so getting back to your questions for your online lab. Letter A says, what happens when we were looking at it, we saw the Earth spinning on its axis. The sun and the moon rises and sets in that 2D view tab, and I showed you all how that sun and moon rose and set. The solar intensity goes up and it goes back down. Feel free to review the video or rewind the video so you can review that part. And then the shadow moves from west to east. Remember, it is a mirror of itself. So when we get to see day and night, it's because the Earth is spinning on its axis. We know that the Earth is going to move a little bit around the sun, but the moon is going to move quicker around the sun. So it's going to complete a lot of circles around the Earth before the Earth finishes going and taking its lap around the sun. We're going to look at the moon completing its travel around Earth in about 1 month. And so that's how we know when our month is over and we're ready to start a new month. But when we are ready to start a new year, that means the Earth has completed its revolution around the sun, that little lap that it needs to take. Again, usually that's 365 days. What astronomical event corresponds with the passage of 1 year? I just finished saying that. It takes a year to revolve around the sun. It does want you to draw that little picture of how the Earth's position changes. And so you're just drawing your arrows showing that you know it goes counterclockwise, which is about 365 days a year, except if it's a leap year, which is 366. Shout out to all of the leap year babies who were born on that leap year day and doesn't get to see their birthday, but every 4 years. So they're 16, but typically because they did their birthday, they're 4. No, they're not. So looking at this, again, y'all, my E stands for east. So I've got my east to my west. So my sun is going to rise from the east to the west. When in number 3, it says describe the position of the red dot once you start the tab, and it's telling you exactly how to set your tabs, which I just went through. But when we're at midnight, that means it's facing away from the sun. That means it's dark, period. Now, just in case you need to see it, which I really don't think you do, but I'll do it. So when you're looking at it, that red dot, when it faces away around 12, that means it's facing away from the sun until it's dark, just to prove the point, in case you're a visual learner. All right, moving on. So the red dot is now on the lit part of the Earth's surface where the sun is shining. And then if you play this, and I'm on activity B, the red dot is now on the dark part of the surface, and that's what I was just showing you. When I'm looking at the Earth that's spinning around on its axis, it looks like the sun is rising in the east and settling in the west. But in actuality, it's just the Earth spinning. The sun is not rising in the east and settling in the west. We just see it like that because it comes over the horizon and we see it come up and then we see it set back down. And so, again, we're looking at that shadow mirroring the sun's path. So it's doing the opposite for our shadows, but east to west is the way the sun appears to travel because the Earth is spinning on its axis. So on this one, it's just a follow-up. The shadow appears to go from west to east, like I had already told you. When the sun is at its highest altitude over us, then our shadows and any other flagpole shadow, any stick, will appear to be shorter. If it's casting from the side or from an angle, the shadow is going to be longer. So then this next part is for you to go to Schoology and complete Activity C. If you don't have a laptop, do your Activity C on your worksheet that you can get. It was already printed out, but complete it on paper and turn that in for a major grade. When you are doing this gizmo, I want you to keep in mind that, let me move this out the way. I want you to keep in mind that Alcorn Middle School has a latitude of 34.0 degrees. That means the lines going from east to west, circling around, the latitude that Alcorn Middle School sits at, that you sit at, is 34. That's going to be important for some of your questions. I'm going to get back to it in a minute. Remember, when you are going to collect your data, it's going to tell you, select the graph. This is the graph one. It's going to ask you to make sure that it's on the day. We're going to look at the solar intensity curve. You saw it just a little bit ago, go up and then go down. It shows you when it got the highest in the day, the solar intensity was at its highest. And when the sun went down, you saw that down here. So we see how many hours of daylight we end up having and how many hours in that day. So it's going to ask you to slide that little red slider down here, looks like a triangle, over to March 21st. You're going to start your simulation and you'll see it go up and drop back down so we can see when your sunrise, your sunset was, and then how many hours between those 2 hours did it happen. So let me show it to you on Gizmos, and then I'll go to, oh look, we were still going. Then I'll go to Schoology so you can see it. Let me reset. Let me drag this right here over to March 21st. Let's see, I'm on March 21st. And then let's get it popping. So when I'm seeing this, March 21st, I see my intensity goes up right about, I'd say like 6 o'clock. Starts to come down and hits right about maybe 18 hours or 1800 hours. So let's go to your Schoology. Just a quick reminder, and of course it's listed by date. When you click on the tab, you'll see the video notes up here for just the notes that we've gone over. You see your definitions. You see your warm-up, which you need your definitions for. And down here is Activity C that goes with the rest of the paper that you saw. Let me hit to this preview. Notice that I write this down. Alcorn Middle School has a latitude of 34.0. So the very first question, I don't know if y'all can see that. What is the latitude of Alcorn Middle School, your town? Type this in with the numbers and the decimal. So I am expecting to see this. It's going to grade it automatically, so hope y'all pay attention to how to type it. Just wanted to make it a little bigger for your screen. Let's see who pays attention on that one. All right, and we're walking. So we have student exploration season. Here are all of the instructions on what you need to do. These are all the instructions I just went over. You're going to fill it in. Here's your March 21st. You're going to do the same for June 21st, September 23rd, and December 21st. What I did do is I put the hours that you would be using, the times that you would be using down here. Some of these you will see copies of, so 12 hours and 12 hours. Is down there 6 hours, 18. But you're dragging and dropping, y'all. When you see those doubles, that means it's going to be used more than once. If you follow the directions that I gave you on here, remember I said it went up at 6, came down at about 1800. So if you look on here, no, I'm not going to do them all, but you're going to drag and drop it. Went from 6 to 1800. 18 minus 6 is 12, so my 12 goes right there. So you're going to do that for June 21st, September 23rd, December 21st. If I were to reset it, take it on over to June, make sure it says June, hit play, and then you'll see it yourself. And then mark the time. If you're not sure what the time is, do a guesstimate of your sunrise. And when it comes and hits back down of your sunset, just do a guesstimate and then choose the numbers that you see that are closest, which is why I gave you choices instead of you having to type it in. So I hope that helps for those who are actually watching the video. So for this one, y'all, more drag and drop. Remember, the sun is rising and setting, but I do expect that the sun would rise either earlier or later when we're looking at the summer as opposed to the winter. And that's going to cause either an increase or decrease depending on the season and daylight hours. So you're going to drag and drop those words and put those in. For this next one, I made it even easier. I need you to select, is this the solstices or the equinoxes? Go back to your notes if you need that. And then finally, I'm asking you for 2 dates for the equinoxes. So you can either go to your notes for these 2 dates, but when you put them in, I need it in this way, the month / whatever the day is, and, yes, right, the word and, month / day. So there's 2 dates I'm looking for with the and in the middle, and then submit it. So I hope that helped. Email me or ask Mr. Glover if you have questions.